Let's be direct. The automotive industry is in the middle of a seismic shift. We're moving from cars defined by their engines to cars defined by their software. And right now, we've hit a critical turning point. Grand visions are no longer enough. It's all about execution. So let's dive into the global strategy for the next 2 years. This quote really hits the nail on the head. It perfectly captures the reality check happening across the industry. The conversation has completely shifted from what might be possible someday to what you can actually reliably deliver to customers. This is the inflection point we're at right now. Okay, so here's how we're going to break this down today. We'll start with the market reality, then we'll get into the core AUTOSAR technology. After that, we'll cover the 3 big tech shifts you have to master, we'll map out the global competition, and we'll wrap up with a concrete engineering playbook you can actually use. So, first up, the reality check. Why is 2026 such a critical year? Well, it really boils down to 2 things. The absolutely massive scale of the opportunity and the fact that the entire value chain of the industry is being completely rebuilt from the ground up. Let's talk numbers. This is the projected global market for software-defined vehicles by 2026, $470 billion. This isn't just some small incremental change. It's a fundamental shift in where money is made in this industry. The stakes, they are incredibly high. And this slide right here shows you exactly where the value is moving. I mean, look, hardware and middleware, they're growing, sure. But the real story is that number in the highlight box, a 34% compound annual growth rate for software subscriptions. This is the financial engine that's driving this entire transformation. A car is no longer just a product. It's becoming a platform for services. Okay, so let's get into the technology that makes all of this possible. How do you actually build these incredibly complex systems? Well, it all starts with AUTOSAR's dual platform core. And a great way to think about this is as the brain and the muscle of the modern vehicle. And here's that brain and muscle idea in action. On one side, you have the classic platform. Think of this as the muscle. It handles the absolutely rock-solid real-time control for things you can't get wrong, like your powertrain and brakes. Then, on the other side, you have the adaptive platform, the brain. This is your high-performance computing hub, running things like ADAS and infotainment. The key takeaway: they're not competing. They're designed to work together perfectly. Now, what's really fascinating here is the market dynamic this chart reveals. The classic platform, that's the established foundation, right? It holds the majority share. But look at that call out for the adaptive platform, a nearly 15% compound annual growth rate. That's the strategic growth engine. That's where the future of automotive software is literally being built. So, with that foundation in mind, let's talk about the 3 major technology shifts that are completely reshaping a vehicle's electrical and electronic landscape. For any engineering leader, mastering these is absolutely non-negotiable. These are the 3 pillars of the new E/E architecture. First, you've got the move to a zonal architecture. Second, the need for high-performance communication. And third, a totally new approach to safety and security. Zonal architecture is a real game changer. The old way was, this complex web of dozens, sometimes hundreds of individual computers. The new way is so much smarter. We group controls into regional hubs or zones. This massively cuts down on wiring, which means less weight and lower cost. But more importantly, it creates the data superhighway we need for things like AI and autonomous driving. And with all this new data flying around from cameras and LiDAR, the old communication protocols just can't keep up. The standard has been some IP, which is fine for simple commands. But now, AUTOSAR is officially integrating DDS, which stands for Data Distribution Service. Think of DDS as a high-speed data firehose. It's built specifically to handle the constant, massive streams of sensor data that autonomous systems absolutely depend on. All right, now for safety. And this is a huge development. For the very first time, we have a compiler for the Rust programming language that is certified to ASIL-D. That's the highest possible level of automotive safety. So, why does this matter so much? Because Rust is famous for preventing some of the most common and dangerous memory-related bugs right at the source, before the code is even compiled. This means we can now build fundamentally safer and more secure code for the most critical systems in the car. And what about AI? I mean, how do you safely manage a system that's non-deterministic by nature? The answer is what's called a guardrail architecture. First, you stabilize the AI model itself. Then you wrap it in a rule-based validation layer that's constantly checking its outputs against the laws of physics. And finally, you protect it with robust input sanitization. This is how we bring the power of AI into safety-critical domains, but do it responsibly. So, with all that tech in mind, let's zoom out. How is this all playing out on a global scale? What we're seeing is three very distinct strategies emerging from the world's major automotive regions. First, you've got Europe, which is playing the role of the fortress. The strategy here is built on standardization, with initiatives like CAPI creating common platforms. There's also a fierce defense of digital sovereignty, and of course, leadership through really rigorous safety and cybersecurity regulations, like UNR 155 and 156. In sharp contrast, you have China, which we're calling the rocket. Development there moves at internet speed. We're talking engineering cycles that are often twice as fast as their European counterparts. This is all fueled by a powerful local ecosystem called AutoSimo, and the huge influence of players like Huawei who are now shaping global standards from a position of market dominance. And finally, there's North America, the cloud. The strategy here is all about leveraging the incredible power of cloud giants like AWS and Azure. The goal is to create a seamless workflow, develop in the cloud, deploy in the car. This enables massive scale virtualization, which accelerates testing, and it directly supports the over-the-air monetization models that are so key to future revenue. Okay, so that brings us to our final and most important section, the playbook. Given everything we've talked about, the market, the tech, the competition, what are the critical imperatives for your engineering teams right now? Imperative number one is to shift left using a multi-level virtualization strategy. You simply cannot wait for physical hardware anymore. By creating virtual ECUs at every level of abstraction, from a basic model all the way to the final target binary, you can decouple your software development from hardware availability and automate upwards of 90% of your testing in the cloud. Second, cybersecurity can no longer be an afterthought. It has to be designed in from day one. In practice, this means using virtual security modules for key storage, securing all internal communication with things like SecOc, and, this is critical, automating the tracking of your software bill of materials, or SBOM. This is basically a list of all your software ingredients, and it's now required by new global regulations. Third, you have to change the workflow itself. Modern cars are just too complex to configure everything manually with a GUI. It's impossible. Your teams must move to a configuration as code model. This means using scripts to automatically generate those complex AUTOSAR configuration files, the AR XMLs, that define the whole system. This is the only way you can get automation, version control, and real collaboration at scale. And all of these imperatives, they all lead to the single governing thought of this entire briefing. The ultimate goal here isn't just to build a software-defined car. It is to transform your entire organization into a highly efficient software factory. Success is no longer measured by individual features. It's measured by the speed, quality, and efficiency of your entire development pipeline. So, I'll leave you with this final, provocative question to consider. Ask yourself, is your organization just a car company with a software team bolted on the side? Or is it fundamentally transforming itself into a software factory that just so happens to build cars? The answer to that question will likely determine your success in this new era.